Good afternoon, Year 11, and here's today's lesson. Here's your answers to the 5-day. Let me know if you have any questions about them. Your title. So today we're looking at an introduction to similarity. Okay, like with congruence, we can show that two triangles are similar by using a combination of their sides and angles. You write down this orange box, please. So for similar shapes, corresponding pairs of angles are equal and corresponding pairs of sides are in the same ratio. Example of two similar shapes. Here, because two of the angles in the triangle are equal, I know that the third one must be equal. This means that corresponding pairs of angles are equal and the triangles are similar. They have met the conditions for the AAA similarity test. To work out the scale factor between the shapes, we take the length on the enlargement divided by the corresponding length on the object. So here, the scale factor to move from the ABC shape to the PQR shape is 1.5. Enlargement divided by object, it's called. Okay, so this is how we answer a question. Sorry, this is how we provide our similarity statements. So here, that the triangle ABC is similar to triangle PQR. We put the AAA in brackets afterwards. I don't need to write these words, I can use a tilde. Now sometimes what you will see is this symbol. I would prefer that you just use the single tilde rather than the two lines with the tilde on top, just in case you're feeling a bit wobbly and all your lines end up being wobbly or all your lines end up being straight and then it gets confused for the congruence sign. So a single tilde is preferable. I think your book sometimes uses this triple one and the exam papers sometimes use it, so you need to be aware of its existence. Now it's really important that the vertices are in the correct order. So A corresponds to P, so A and P are in the same position in the list. The triangle ABC is not similar to QRP, for example. Pause the video or have a think about this question. What shapes are always similar? So all regular shapes are, so squares, equilateral triangles, regular pentagon, hexagon, heptagon, and so on, and circles are always similar as well, of the 2D shapes. Okay, so these are the 4 different tests that we can use. You'll see that 3 of them are the same as the congruence tests, but we use them as improved slightly differently. AAA, it's quite common that people get mixed up and start using AAA to prove congruence when it definitely doesn't do that at all. AAA is only used in proving similarity. And so the AAA one is if 2 angles are respectively equal to 2 angles of another triangle, 2 angles of one triangle respectively equal to 2 angles of another triangle, then the 2 triangles are similar. This one gets used a lot. SSS. So if the sides of one triangle can be matched up with the sides of another triangle so that the ratios are constant, so for example 5 over 2.5 is equal to 3 over 1.5 is equal to 6 over 3, and it must be all 3 sides of a triangle, then they are similar. SAS is we've got 2 pairs of matching sides being in the same ratio with each other and then the angle between them being equal. So here you don't know this, it's just that I'm stating it. So for example, I might have something like this is 2, this is 6, this is 9, and this is 3. So A dash B dash over AB is the same as A dash C dash over AC, and the included angle is equal. RHS, so ratio of the hypotenuses and one of the other sides, and both have a right angle. Okay, let's have a look at a question then. So have a look at the diagram there. We need to say which two triangles are similar and give a reason. So I can say that angle ACD is equal to angle ABE because they're corresponding angles with parallel lines EB and DC here. You can also say that ADC, angle AEB, are equal because they are corresponding angles in parallel line or with parallel lines. Now that's enough to show that two the same, because if two of the angles are the same, then I know that the third must be. But just to be extra rigorous, I can also say that DAC is equal to EAB because it is a common angle. There I've accounted for all three angles, which is preferable to do because it just adds in another layer of checking to your work. So I can say that ACD is similar to ABE. My reason is AAA. To find the length CD, it's much easier if you separate the triangles into their two separate ones. Just draw a quick sketch. Make sure you put the letters on the vertices, so when you're naming things you don't accidentally name the wrong thing. Write any lengths that we have. So in my ABE triangle, I know that this is 4.8 and this is 6. In my larger triangle here, this side AC is the sum of those two sides, which is 10, and I'm trying to find CD. I know that the ratio of the sides are equal, so AC over AB, AC corresponds to AB, is equal to DC over EB. Now, there's a variety of different permutations of writing these sides together. We could say that AC over DC is the same as AB over EB. I could have the reciprocal of each of these fractions. What you're aiming for when we substitute the things in that we know is that the thing you're trying to find wants to be in the numerator of the fraction, really, just to minimize the places where you might make silly mistakes. But if it ends up in the denominator, that's fine. Hopefully your algebra is strong enough to work with it. Okay, so there we can multiply by 6 to give us this. Okay then, these are your questions for the rest of the lesson. I'm still trying to think about sorry, I thought I just put all the questions up. Still considering what I'd like to do with you tomorrow. Could you let me know by the end of this lesson how many questions from today and yesterday you've got through? We can push on with the next exercise tomorrow if you like, or we can spend some time going over exercise 9 F from today and the congruence one from yesterday. Just let me know how you think you're going. Thank you very much. Remember to post any questions on the discussion.